Welcome back to Old Ducati Girl. Now, when I got this motorcycle, Dave, the previous owner, had rewired the bike beautifully, did a beautiful job. He also replaced the throttle with a nice dual throttle cable unit. Problem is, the old one had a electrical switch for a kill switch. The bike did not have a kill switch. So you had to reach across the tank around the other side to shut the motor off, which is really awkward in a pinch. So I decided, well, let's make a kill switch. I'd looked online. I didn't really see anything that wasn't too clunky and weird, so I thought, well, we can make one. We have a CNC machine here. So this is the story of where the kill switch came from. And so we'll take a look at how that was built, the deep, deep engineering process that occurred. Thank you. So here's the brake lever assembly, and that, where you see those two gold screws, is the rear half of the clamp, which is just a half moon kind of piece of metal. So what I plan to do is take this block of aluminum here, and we're going to put that shape into the right-hand side of this block. And then the left-hand side of the block is where a switch is going to go, and I think an LED. And so that'll be the kill switch. And the block is 1.750 tall, which is about the same height as the clamp is right now. So what we're going to do, because I don't really know what this thing's going to look like. So first thing we're going to do is we're going to put the half moon shape to fit the handlebar into this block. And then I'm going to see how much room I have for the other bits and pieces. So that's the starting point. This isn't really to a blueprint, so we're going to feel our way through it. So let's go over to the milling machine. So we're going to take an orbital cut on this block and put in the handlebar contour with an end mill. And the end mill is going to do an orbital cut. I'm only going to do it 1/10 of an inch deep without coolant because I don't want to make a mess that might get flung towards the camera. But it's going to be 875 deep eventually. And it's offset to the right by 40 thousandths of an inch to allow the block to pinch. They don't truly come together, so it's not quite a full semicircle. So let's start the mill up and give that a look-see. So we're going to repeat that cut by about 6 or 8 times, and then that's the beginning. So we're going to cut a matching contour here to match the handlebar contour on the top of this cap. So here we go. There we go. And that's going to match that contour. And it'll be 7/8 of an inch deep also. I'm not going to show you all those cuts either. It's just a tentative. But you can see how it's starting to look like a handlebar cap. mill the pocket for the switch. And I pre-drilled it to make the mill's job a little easier. So let's start this program up now. So there's the pocket. I'm only going to do one layer. So here's the pocket for the switch. And I've also cut away the upper area where the hole for the switch comes out. There. And the surface behind that hole going vertically, I'm going to run a mill into it such that the hardware and the lock washer of the switch can fit on that boss there. So there's the switch all mounted up. Its lock washer fits, and I can even get pliers on the hardware to tighten it up. So what we're going to do is we're going to angle that material back away from the switch now so it's not so bulky up above. So here's the finished switch block. You push the switch inboard and like that, pull it in, shuts off the motor. There's an LED indicator for when ignition is on. And underneath there's a little hollow there for the switch and a dropping resistor. You can't put an LED directly on 12 volts. It's too much voltage, so you have to put a resistor. 1200 ohms, about right for a standard LED. And the LED grounds to the switch block, which will ground through the handlebars. Now, at first I thought I was going to have to run a clip lead and a wad of tin foil and stick that between the fins on the barrels, but it turns out the handlebars are at ground potential, so it solves that problem. And over here, well, that's about a 1970 Tektronix oscilloscope, and it's a handy electronic tool. It has nothing to do with putting a resistor on an LED, but it makes for nice video. So back to the switch. Let me put the ground lead on here. Okay, there's ground. Oop. Come on now. Stay put. So, there we go. Nice bright LED, which will be on to remind you that you're lit up when you want to start the bike, and when you push that inboard, light goes off, life is good. Since I've taken the gas tank off, I thought we'd take a little diversion for a moment and go have a look at the motor. You have to get up close to this engine to kind of see what a mad piece of machinery it is. The thing that's so weird is the way one carby just kind of shoots off the engine to one side and then come around to the rear, and the other carby just kind of shoots off at a whole different angle, kind of swooping up to here. And it's a very mechanical piece of business. It's like you had a tropical disease and your brain swelled up, and then you dreamed up this engine. And oh yeah, down here, this is the end broke off the gear shift lever, so I created a little block with a right angle on it to replace that part. You can't really find the levers, and they're pretty fragile, so this should hold up. Anyway, while the tank was off, I thought I would just show you the Delordos and the wackiness that goes on under the hood. So here's the finished kill switch here, and it's a nice bright LED. You can kind of see it. So that's ignition off, ignition on, and you can just reach over from the throttle and hit it with your thumb, even with a glove on. So mission accomplished. Well, I hope you enjoyed the CNC kill switch project. That was about the last roadworthy needed modification on the bike since I got it. Most other things seem to be working pretty well for at least going for a drive and feeling, if not normal, quasi-normal. And I think I heard Mustafa prowling around out here, but he seems to be gone right now. Anyway, send flowers or hit the subscribe button. Ciao.
Well, I can only suppose that the imbecile has told you all about her amazing inventions, and she thinks she's an engineer. I will tell you about a real engineer. My uncle was the chief engineer at the great steam calliope at Ankara. No one could do what he did. He was a mechanical genius. She is a mechanical moron. Do you know she has the great machine out there? Come with me. I will show you. You see? Do you see? Paper and tape taped over half the buttons. She has no idea how to use this machine. It makes me crazy.